So we're going to be doing number 19 on page 74. A man pushing a mop across the floor causes the mop to undergo two displacements. The first has a magnitude of 150 centimeters and makes an angle of 120 degrees with the positive x-axis. The resultant displacement has a magnitude of 140 centimeters and is directed at an angle of 35 degrees to the positive x-axis. Find the magnitude and direction of the second displacement. So I have a drawing right here. I've labeled the first vector A, the resulting vector R, and the second vector B. In order to find the magnitude and direction of the second vector, we're going to have to solve for B. And this equation is saying that A plus B equals the resulting vector, which is true. And because we know R and A, we just need to solve for B, which is going to be R minus A vectors. And we want to find both the x and y components of all three of these. So in order to find the x component of R, we're going to label this as the x component of R, and this the y component of R, because this plus this is going to be this. And we want to find this, and we know cosine of 35 is going to be adjacent over hypotenuse. So if we just try to solve for the adjacent part, that's just going to be 140 centimeters times cosine of 35 degrees. And if you calculate that, you're going to get 115 centimeters, and this is going to be positive because it's in the positive direction. Similarly, we're going to solve for y component of R, and that's just going to be opposite times hypotenuse. And if we just solve for the opposite part, that's just going to be 140 centimeters times sine of 35 degrees. And if you calculate that, you are going to get positive 80.3 centimeters. Again, it's in the positive direction. Now we're going to have to solve for the x component and y component of A, which we'll also label. So that's the x component of A and then the y component of A. And we know this theta is going to be 60 degrees because 180 degrees minus 120 degrees is going to be 60 degrees. Now we're just going to have to solve for the x component of A, which is just going to be adjacent over hypotenuse. Adjacent over hypotenuse is going to be cosine theta times 150 to find the x component. 60 degrees. And we're going to get negative 75 degrees here, because the x component is actually in the negative direction. If this is positive, then this is going to be negative. But the y component is still just going to be positive because it's in the upward direction. And to find the y component, we're just going to do opposite over hypotenuse, which is going to be 150 centimeters times sine of 60 degrees. And that's just going to be positive 80.3 degrees. Excuse me. It's going to be positive 130 centimeters. The components of the second displacement, which is B, we're just going to have to do the x components of R minus the x components of A, and then the y component of B is just going to be y component of R minus y component of A. If we solve for both, because we know both the x and x of R and y, if we calculate that, that's just going to be 190 centimeters. And then same for the y's, that's just going to be negative 49.7 centimeters. Now the magnitude of B is just the distance formula which is b of x squared plus by squared. It's just the hypotenuse formula at the end. And it's going to be 190 centimeters squared minus, well, plus, minus 49.7 centimeters squared under the square root, and that's going to be 196 centimeters. So that's our magnitude of B. Our direction of B, if we look back at this picture, is going to be this and this. So this will be the y component. This will be the x component, and this will be the y component. So bx and by, and that's just going to be theta for B. If we want to find the theta of this, we're just going to have to do opposite of our adjacent, which is tangent theta, right? And we both know that the y component of B and the x component of B. So if we do tangent theta equals opposite over adjacent, we just do inverse tangent. We have by here and bx here. So we calculate that tangent theta equals negative 49.7 centimeters over 190 centimeters. And we're just going to take the inverse tangent of this fraction to find theta. And if we calculate that, we're going to get negative 14.7 degrees. So the magnitude of B is 196 meters, 14.7 degrees below the positive x direction.